Hello friends, I'm James. Part of a linear programming question on national exams seems to have part A always about quadratic functions. Something typically like this. Given a function f of x equals x squared minus 6x plus 2, please find three things. Find its axis of symmetry, find its turning point, and find its maximum or minimum value. Okay, so let me just do this type of question first, and here's how my brain works on this. The key thing about quadratics, x squared type functions, is that the graph of any quadratic function is a symmetrical U-shaped graph. It's, well, not really U-shaped, actually, bends like this, but a graph like this. And people, I guess, call this the turning point, which if it's facing upwards like this would be a minimum, but if the graph is upside down, it would be a maximum. But the key thing is symmetrical. Because once you've got symmetrical in your head, that these graphs are symmetrical, then everything follows. For example, before I answer this question, let me ask this question. A quadratic graph goes through 3, 15 and 7, 15 and has max value 20. Sketch it. Alright, so there's my made up question, made it up on the spot. A quadratic graph goes through 3, 15 and 7, 15 and has a maximum value of 20. Please sketch the graph. Okay. Oh, I've given myself no room. Let me do this. So it's a quadratic graph that goes through 3, 15, 7, 15 and has a max value of 20. Okay, there's the core information. So let me now sketch the thing. The key idea is it's going to be symmetrical. And I've given you two symmetrical points on a graph that's going to be symmetrical. Look at this. I can sketch this very well. 3, 15. 3, 15 must be there. 7, 15. 7, 15, same height. Two symmetrical points on a symmetrical graph. So now I know the graph is going to be, well, actually, common sense. It's going to be symmetrical about the middle value. What's halfway between 3 and 7? 5. So the axis of symmetry must be at x equals 5. And the trouble is I don't know if it's going down like this to make an upward facing graph, or maybe it's the other way around, downward facing graph. But its maximum value is 20. I know by symmetry the maximum value is going to be up here at 20. Oh, the graph must be like this. Woo! Beautiful. Symmetry. Once you've got symmetry in your head, everything follows. Even this exam question follows. So quadratic graphs are symmetrical. So let me now answer this question. The key is to try to find those two symmetrical points on this graph. So we've got f of x equals x squared minus 6x plus 2. Can I find two symmetrical points? Can I find two x values that give the same output? And I scratch my chin for a while and think, I want to focus on the x values. So let me just focus on the x part. And the only thing I can think to do is a little bit of algebra. Rewrite this as x times x minus 6 plus 2. Because as soon as I do that, because when I see x is 0 or x equals 6, they're staring me in the face, x equals 0 and x equals 6, I get that x equals 0 gives f of 0 being 0 times something plus 2. It's 2. When x equals 6, 6 times 0 plus 2. f of 6 is 2. I've now found two symmetrical points on a symmetrical graph. At 0, I get 2. At 6, I get 2. The axis of symmetry, common sense. Two symmetrical points on a symmetrical graph must be right there at 3. The axis of symmetry is x equals 3. Where's the turning point? Well, it's somewhere on there. How high? How low is it? I don't know. But we can just put in x equals 3. Oh, put in x equals 3. I get that f of 3 is 3 times negative 3. That's negative 9 plus 2 is negative 7. Oh, it's down here at negative 7. Whoops. My board technique's not very good. So actually my graph looks like this in my mind. They didn't ask me to sketch it. But now I can see it has a minimum value at x equals 3 with minimum value of negative 7. There it is. Symmetry. So as soon as you see symmetrical graph, see a quadratic graph, think a symmetrical graph and look for symmetrical points. For example, this one. I'll do one more. So if they made the exam question this instead, which would be probably too hard, but I bet we could do it, 2x squared minus 8x plus, I don't know, 17. Whoa, whoa. My brain says, okay, that's still quadratic, still symmetrical, so let's focus on the x part and try to find two symmetrical data points. So we've got right now that f of x is 2x squared minus 8x plus 17. Let me focus on the x part because I want to focus on interesting x values. 2x times x minus 4 plus 17. Oh, which makes me think, oh, x equals 0 and x equals 4, interesting. When x is 0, I get 17. When x is 4, I get 17. So I know my graph is going to look like this in my mind. At 0 and 4, it's 17. 17. Oh, common sense. The axis of symmetry must be right there in between at 2. Got it. And where's that turning point? Must be something like this. Or it could be lower, or it could be higher. How do I know? Let's put in x equals 2. At x equals 2, we get 2 times 2, that's 4. Take away 2, that was negative 2. 4 times negative, that's negative 8 plus 17. We get that f of 2 is, what did I say, negative 8, that's 9. Oh, so it's actually here at 9. Beautiful. Minimum value being 9. Symmetry, symmetry, symmetry. So part A of these linear programming questions use the power of symmetry. Next, let's talk about part B type questions.